Hey guys, and welcome to lesson 4.3, the sum and difference identities for cosine. Now, normally what we do is go through a proof as to why these identities exist. I think that's probably more appropriate for the classroom setting. So what I'm going to get you to do is take a second and just kind of write all of this stuff down. And this is something, like I said, most definitely we'll be going through in the classroom. Scrolling down a bit more, this you have on your template, and this is the proof as to why the first identity, which is the difference identity for cosine. The important thing here is to write down the identity so that cos of two angles that are being subtracted, so cos of x minus y, ends up being cos of the first angle times cos of the second angle plus sine of the first angle times sine of the second angle. So what we'll do now is use this difference identity to come up with the sum identity for cosine. So what we're going to do now is create the sum identity for cosine. Now in the previous page we had the difference identity. Inside our argument here, we have an x plus y. I can rewrite that so it looks like the difference identity. I can say that this is cos of x minus negative y. Okay, so two negatives make it positive, so that's why I can rewrite it like this. But writing it like this lets us use what we already know to create this new identity. So using the difference identity, I can say that cos of x minus negative y is cos of the first angle times cos of the second angle plus sine of the first angle times sine of the second angle. Okay, so once we're at this point, the important thing here is to remember the relationships that I showed you on the first page. So I'll just recall those, and that'll help us simplify a little bit further. So for our first term here, we have cos x. Not much we can do with that. But it says cos of negative y. Now if I look to the right here, cos of some negative angle is just positive cos. So I'm going to replace that with positive cos y. Now for my second term, we have sine x. Again, not much we can do there, but it's being multiplied by sine of some negative angle. Now, sine of some negative angle is really equal to -1 times sine of that angle. So essentially what we have here is this entire term is going to become negative. So I'm just going to put that negative sign there, and then times sine positive y. So to finish this up, we have cos x, cos y, and then plus some negative term. So really it's just subtract sine x times sine y. So our sum identity for cosine is cos the first angle times cos the second angle minus sine the first angle times sine the second angle. Alright, so we have our two identities here, the sum identity and the difference identity, which is at the top of the screen there. So let's go ahead and use those in some examples. So in this example here, we have cosine of some argument. Now inside the argument we have two terms that are being subtracted. So we're going to use the difference identity. So here's the first and here's the second. So the difference identity is cos of the first times cos of the second, and then the difference identity has a plus sign in between. then sine the first, and sine the second. And then from this point we can simplify. So using either special triangles or properties of the cosine graph that we already know, so I'll just kind of sketch it to the side here. Now if I wanted to evaluate cos at 3 pi by 2, well, I'll take a look at the graph, and I see that the graph hits 0 when the angle is equal to 3 pi by 2. So I can do that substitution here, and I can say that cos 3 pi by 2 is equal to 0, and then we'll just leave cos x because we don't know what x is. Similarly, we can do the same thing with sine. So again, I'll sketch it to the side here, and I notice that sine 3 pi by 2 is actually at -1. So I'll do that substitution as well. And we can just simplify. 0 times anything is gone. It equals 0. So what we're left with is negative sine x as our final answer. Okay, we'll move on to example 2 now. Another evaluation question. So I have cos of two terms that are being subtracted. So same idea as last time. Expand using the difference formula. So cos of the first term times cos of the second. And because it's the difference identity, I'm going to put a plus sign in the middle. Sine the first and sine the second. Each one of these trig ratios are things that we can evaluate. We know using special triangles, which I will put up on the board here for us, we know that cos of pi by 4, so we'll look at this triangle here, is really just 1 over root 2. 1 over root 2, and that is being multiplied by cos of pi by 6. It's just root 3 over 2. Plus, then we're working with sine of pi by 4. 1 over root 2 is sine of pi by 4, and then multiplied by sine of pi by 6, so times 1 over 2. Alright, so we have two terms here. In the first term, numerators times numerators, denominators times denominators. And in the second, we have the same idea. And if you wanted to collect it all so that it's one big fraction, we have a common denominator already, so all we need to do is add the numerators. Now, a lot of the times you'll see that you'll need to rationalize these denominators. So what that means is that your denominator should not have a root sign. So what we do is we multiply by 1, but we do it in a special way. So for example, we want to get rid of this root 2, so I'm going to multiply by 1, but I'll do it so that the 1 is equal to root 2 over root 2. Okay, so the reason that we do that is if we're looking at the denominator, so denominator times denominator, we're going to have 2 times root 2 times root 2, which ends up being root 4. And then what that ends up being in turn is, well, we know what root 4 is. That's just 2. So really the denominator has just turned into 2 times 2, which is 4. Now working with the numerator, you'll have to do some distribution. So take that root 2 and multiply it inside the bracket. Root 2 times root 3 ends up being root 6, and then root 2 times -1 is -1 root 2. Okay, so let's try again. I notice here I have cos of some argument where there's two terms, but this time there is a sum. So we'll use the sum identity for cosine. So cos the first term times cos the second term. And because this is a plus sign, we do the opposite for the cosine identities. And I'll put a minus there. So we'll end up with sine the first and then sine the second. And again, we can use special triangles to evaluate. So cos of pi by 3 using our special triangles does end up being 1 over 2. Cos of pi by 4 is 1 over root 2. Sine of pi by 3 be root 3 over 2. And then sine of pi by 4 again is just 1 over root 2. Two terms being subtracted. First we will multiply the first term. So numerators times numerators, denominators times denominators, and same on the other side. And again, we can write that as one single fraction because we do have that common denominator there. So we'll end up with 1 minus root 3. Again, we can rationalize, and the thing we want out of the denominator is the root 2. So we are multiplying by 1. Okay, so up top we're doing the distribution. 1 times root 2, and then negative 3 times root 2. And in the denominator, it's 2 root 2 times root 2. Now we already know from the other example that it really ends up being 2 times, well, root 2 times root 2 is root 4, which ends up being 2. So to finally simplify this one, we end up with root 2 minus root 6 all over 4. Okay, and one last example, which is a fairly common example, so I would maybe highlight this or put a star. You'll see this a few more times before we finish this unit. So we are given that cos of angle A is 3 over 5, and sine of angle B is 12 over 13. We also know that angle A is in quadrant 1 based on this here. So angle A is between 0 and pi by 2, which is quadrant 1. And we also know that angle B is in the second quadrant because of that information there. So given all of this information, we want to find the value of both cos A plus B and then cos A minus B. So if you'll notice, remember that the expansion for the sum identity and for the difference identity both had cos of both terms and had sine of both terms. Well, I only have cos A. I know in the future I'm going to need cos B. And again, I have sine B, but I know very shortly we're going to need sine A. So what we'll do is, okay, so first we will find sine of angle A. Okay, based on cos of angle A, remember from last chapter that cos is really just x over r. So for us to find sine A, we need to know the information for y over r. Well, we have r, we need to find y. So what we'll do is use that Pythagorean identity and use that to find y. So we know our x value is 3. We don't know the y value, but we do know that the r value is 5. So if we go ahead and simplify, remember when you take the square root, you must have plus or minus 4. But we don't need both of those values. And that's where this information comes in. If angle A is in quadrant 1, which is right in here, would our y value be positive or negative? Well, it would be positive because all y values in the first quadrant are positive. So we will use y equals positive 4. So now we can go ahead and find our sine value. So sine of A is going to be y over r, which is 4 over 5. Before we move on, we have to find cos B. So same idea. We know that sine is y over r. And to find cos B, we need the information for x and r. So again, we'll do Pythagorean identity. and fill in what we know. Well, we're trying to find x, so we'll leave that as is. We know the y value was 12, and we know the r value is 13. So we'll go ahead and simplify there. And again, when you're taking the square root, you must consider both positive and negative 5. Again, up in the question, angle B is in the second quadrant. So we know that our terminal arm stops in there. We need to ask ourselves, is the x value in the second quadrant positive or negative? Well, if we went left along the x-axis, we would have a negative 5 here. So we will use x as negative 5. Okay, so that tells us that cos of angle B is really negative 5 over 13. Okay, so I'll just kind of summarize what we have before we can go ahead and do the question. So basically, we're going to use all of this information to answer the question. So the first one was the sum identity for these two angles. So cos of A plus B. Well, if we were to expand that, cos the first term times cos the second term minus sine the first term and sine the second. Now we can fill out these values. So cos of A we said was 3 over 5, and cos B was negative 5 over 13. Minus sine of A, which is 4 over 5, and sine of B, which is 12 over 13. And from this point on, it is just arithmetic. So tops times tops, negative 15 over 65 minus 48 over 65. And because we have a common denominator, we can just subtract the numerators, which gives us a final answer of negative 63 over 65. Alright, now for part B of the question. Part B was the difference identity. So cos of A minus B. And again, if we were to expand that, we'd have cos A times cos B, this time plus sine A times sine B. We've already evaluated cos A times cos B, but this time we're going to add it to sine A times sine B. Because we have a common denominator, it's just adding the numerators together, which gives us 33 over 65. Okay, so that is it for tonight's lesson. Again, if you have any questions, make sure you ask in class. Take care, guys.